Ladies and gentlemen, please welcome Technical Fellow, Microsoft Corporation, Mark Rasinovich.
You want? Yeah, the duck. Here was the duck. One of you is the lucky winner of the duck. I don't know which one yet, but all right. So why don't we get started? My name is Mark Rasinovich. You might have seen me in the keynote talking about Windows Azure Virtual Machines. And in this afternoon session, I'm going to take you deeper into some of the things that I showed you this morning. I'm also going to take you deeper into the virtual networking capabilities that we've also added as part of this release. And to set the stage for how Windows Azure got to where it is and how we're releasing now what some people thought we would never release, infrastructure as a service, let me talk about the philosophy that has set the tone at the beginning of Windows Azure and how it's evolved over time. How many people have been using Windows Azure since its initial release back at PDC 2008? So quite a few of you. And you know back then, it was designed with the promise of PaaS, Platform as a Service, where you just worry about the application, we worry about the virtual machines and the runtime, you give us the app, we'll deploy it, and then you get some nice benefits with that model of stateless scale out where you're not having to worry about the infrastructure. So one of the things that we quickly realized as people started to use the platform is that they had lots of existing apps and components that they wanted to bring onto the platform that they just couldn't because our application model was so restrictive. It was partial trust ASP.NET, essentially. So over time, you can see that we started to add things to relax the constraints of the platform and allow more code to be compatible with Windows Azure's PaaS. We added, for example, full trust in native code in PDC 2009. We added PHP and Java support. Then we RTM'd, and then you can see that we added VM Role Connect, which was the ability to create a hybrid connection from the cloud back to a machine on-premise. More importantly, though, we added admin mode, and that a lot of code that runs on Windows needs to run with administrative rights like setup programs. So if you had something like that, we needed to support that. We also added startups tasks, again for things like setup programs, full IaaS, remote desktop, and then you see that we fleshed out some of our cross-platform support in November 2011. We call those features that allow more code to come onto Azure on-ramps. It's on-ramps from the existing world of Windows Server to the future world of Platform as a Service in Windows Azure. And really that journey takes a big step now with what we're introducing now, which is Windows Azure Virtual Machines. In Windows Azure Virtual Machines, our goals are listed on this slide. So when we started out saying, okay, let's take that big on-ramp step and make it so people can bring existing server applications up to Windows Azure's, how do we define success? What are we shooting for? The first thing you see is that IT Pro experience, which means that we want to have it fully scriptable, automatable. You don't have to be a developer to get to use the virtual machine capabilities. You use the skills that you've already got. We wanted to support key server applications. And we actually used one particular application, you can probably guess, as the one that we would measure our success performance-wise and compatibility-wise. Anybody guess what application that is? No? Well, not close, but there's something more foundational than even SharePoint. SQL, right. So we said SQL. We got to run really well with SQL. So we started working closely with the SQL team to make sure that our performance was tier 2, tier 3 kind of performance, top of mid-tier 2 performance for SQL. That was a key goal. We also addressed other apps, as you saw this morning. Easy storage manageability. How many people use EC2 from that company that's across the bridge from us in Seattle? So just one of you, the rest of you are being polite and not raising your hands. So no, thank you. So actually, one of the things that you notice about the way they architected their storage solution is that they've got things in Elastic Block Store, EBS, which is kind of almost a roach motel. It's very hard to get stuff into and out of that. We decided up front, let's make a big bet on Windows Azure Storage. We've got a fantastic high-scale storage system already. We've got a rich API surface, management tools already developed for it. So let's go big there and put VHDs inside of Windows Azure Storage. That gives you the easy migration into and out of the cloud that you saw this morning. High availability features were crucial, of course. If we're going to be appealing to enterprises, we need to make sure that they can run apps that are scale out, as well as remain highly available in the face of hardware failures in the data center. Advanced networking that you saw, the connection back to on-premise that I'll talk more about was another goal. More rich connection than what we had with the Windows Azure Connect, which was just point-to-point, server-to-server. And then finally, a key goal of ours, and I think what really differentiates us. So already we were differentiated, and we kind of set the benchmark for rich platform as a service is integrating the two worlds, not having them sit side by side. Like if you want to do virtual machines, you're over here in this world. If you want to use PaaS, you're over here in this world. We started at the beginning saying we want those worlds to be one world connected together. How many people are familiar with the virtual machine role that we introduced about a year and a half ago? Anybody? So a few people. This is what actually a lot of people thought when they saw this, said, oh, Microsoft's doing infrastructure as a service. And because of the name, obviously, virtual machine role. I can take a virtual machine and put it in Windows Azure. But when people started to play with it, they realized that it was almost a bait and switch. It's kind of, I guess, the feeling that people conveyed back to us. These aren't really virtual machines. You're not really supporting server applications. And the reason why is fundamentally the fact that these are stateless virtual machines. They're stateless the same way that our platform as a service virtual machines, our web and worker role, are stateless in that if you make changes to that running virtual machine, if a server fails in the data center, you've just lost those changes because we're going to reincarnate that virtual machine with a brand new set initial image, the initial VM image that you gave us. So if you have a SQL database in there, you write the data, you're going to lose it on a failover. And most people like to keep the data they put in SQL Server. So this was kind of like people said, oh, great, oh, and then that was kind of the reaction. Now, it does serve its purpose, though, in the platform as a service world for long-running installs, fragile installs, where you can give us a baked image with the install already there, so you don't have to have this stuff running in deployment time, provisioning time up in the cloud. But, of course, with true virtual machine support means, hey, we want to make sure that you can create a virtual machine, you can treat it exactly like you would a virtual machine on-premise. And we wanted to start out with a nice set of initial base platforms. Of course, this is what we've got coming out at Preview, and I want to set context here for what Preview is. Preview is our initial release. You can kind of think of it as a big beta. And what we're going to have then eventually is a general availability release where we have it fully fleshed out and fully tested at this kind of scale that we're going to have when we turn it on and anybody can join. So right now we're gating access to virtual machines. You guys can all request access, and we'll make sure that you get it so that you can play with the virtual machines. But this is what we've got now. And everything I'm going to be talking about in this presentation is what we've got now. I'll be giving some hints about what we're going to do as we go towards general availability, but it's only going to get better from here. So starting with the platform images you saw in the Create wizard that I showed you this morning, these are the platform images, including these Linux distributions that we ended up getting on board with our platform. And then Scott, if you saw Scott's foundation session, how many people attended that? Right before lunch, quite a few of you. And you heard the message this morning. Again, because it's Windows Azure Storage effectively triplicates the writes on the back end, so it's highly durable. So any failure of a machine in the data center, and we're able to recover the data, plus we've got asynchronous geo-replication happening as well, and you just get that automatically. Speaking of disks and images, so let's start with some basic principles of our virtual machine support. We've got two concepts. One is the images concept, and one is the disk concept. With the images, these are generalized virtual machine VHDs that you can go create new virtual machines from. So they'll do sysprep specialize on their first boot, taking the computer name, taking the other attributes, the administrator password, the other settings that you normally configure when you start to clone virtual machines. You can create your own images as well. So we've got the platform images, but you can take any running VHD, and then using APIs, you can save that VHD into a generalized form, stick it in a library as an image, and then use that as an image that you're going to go start provisioning. So you could go install software in there, for example, and use that to create further virtual machines. And then we have disks. Disks are, of course, something that's not something that you can take and create new virtual machines from, or clone virtual machines from. They can, however, completely contain a virtual machine. So it's not just data that's represented in disks, although if you've got a data disk that you attach to a virtual machine, those are going to show up in disks. But you can also create a disk from a running virtual machine. Like I shut down my virtual machine, I've got a VHD there, and it's a disk. And what I can do then is go create another virtual machine and point it right at that disk and just launch it. So it's not going to re-specialize because you never generalized it. It's going to basically reincarnate that virtual machine with the new characteristics you've given it. So that's the distinction between images and disks. You can think of the images as being generalized images. We also wanted to make sure that we supported big scale applications that have a lot of data. So you can see here, these are the VM sizes we've got today. Everything from the shared core extra small all the way to the extra large 8-core machine. And the number of data disks you can attach to the virtual machine depends on how many cores, the size of the VM, all the way to 16. If you're familiar with Windows Azure storage, you know the largest size of a page blob, which is the kind of blob, there's page blobs that we've got as backing these things. And anybody know offhand the largest size of a page blob in Windows Azure storage? Just as a trivia question. No, it's not 100 megabytes. No. It's a terabyte, right. It's a terabyte. So you can add up to 16 1 terabyte disks to a virtual machine. And then what you can even do is stripe them using striping inside of the operating system to create a 16 terabyte striped disk. I'm going to show you that in a second, actually. But let's talk about the implementation underneath of the disks when you attach them to virtual machines. There's two caching policies we've got at your disposal. One caching policy is that there's a write-back cache sitting on the server where periodically, and when the VM issues write-throughs and flush buffer commands out of its storage stack, will flush and write things back to Windows Azure Storage. But it's cached locally so that you can have quick access to it for read access, for example. And then we've got this other mode, which is no caching. So every read and write goes directly to Windows Azure Storage with no stopping in a local cache. You can see the defaults that we've got on the OS disk and the data disk. So if you go to the portal and you create a virtual machine and add these disk types to it, these are the caching policies that will be there underneath. Using PowerShell scripts, you can create virtual machines with your own caching policies. But what this is optimized for is operating systems have a lot of locality for read and write. And you get better performance for working sets that don't fit in the VM's RAM and don't fit in the server host cache that we've got provisioned for it if you go directly back to Windows Azure Storage. Windows Azure Storage can deliver a tremendous number of IOs per second, much higher than we can achieve with a local disk attached to the machine. So the reason that we've got data disks separately is we figure people that are creating virtual machines where they're going to host serious databases are going to follow the standard practices of I have my OS disk and then I create my data disks. That's where we're going to put my log files and my databases. And we want to optimize performance of the disk caching for that scenario there, where the OS disk has the locally optimized, locality optimized caching, and the data disks are optimized for things like SQL. So let's switch over to the portal. And what I'm going to do is demonstrate what I just showed you. If we go into here, I've got a virtual machine that we just created literally just a few minutes ago. Server 2012 machine with 16 disks attached to it. And you can see number of disks 16. We've got the OS disk here. And then we've got all those 16 data disks attached to it. They're all 1 terabyte Windows Azure blobs. And I'm going to RDP into it. And once I've RDP'd into it, what I can do is show you just how we've got those disks visible in the operating system, and I can stripe them. And I also want to highlight one other thing while we're in here, and that is this temporary disk right here, because by default, your VMs are going to have this D disk, which is where the paging file is going to get created. Now, this disk is like the PAS resource disk, if you're familiar with Web and Worker Role, the same one where the paging files are stored on those VMs. You got the same thing happening here, where this is a local differencing disk or dynamic disk that's on the local server. There's no reason for us to back this with Windows Azure Storage, and paging files are typically very random I/O, and we can satisfy the locality requirements of them by caching them locally. So that's where the paging file goes by default. You can, of course, change that if you'd like to. And then you can see these other disks here. Actually, let me go back out to full zoom and scroll down, and you can see all the disks that we just attached. And then what I can do is say that I want a new striped volume, select them all, assign a drive letter, say that I want a quick format, and in a few minutes, this is going to first convert them from basic disks to dynamic disks, and then it's going to create a stripe across them. And then we can create our massive SQL database on that stripe. While I'm here, let me just talk just for a second about performance in Windows Azure Storage and how that relates to virtual machines. Windows Azure Storage is an adaptive storage system. So what happens is if you don't hit your blobs very hard, it's going to basically leave them on one server, of course with the replication, but it'll leave them on one server on the back end in Windows Azure Storage. If you start to hit it hard, what it'll do is find the hot spots and then split the blob across multiple servers. And it's approximately every 10 minutes it'll do more splits, up to about 4 or 5 splits. And according to the current implementation, Windows Azure Storage is always evolving. But that means that the harder you hit your data, the better Windows Azure Storage will optimize for that access pattern, and the better performance you'll get. So one of the things we recommend if you want great performance out of these things, especially if you're going to like do a benchmark to kind of see where things are, is to warm it up. Warm it up for an hour, and then go start measuring. Let Windows Azure Storage learn what you're trying to do. And then you can see we've got our giant disk here that we've got creating from our stripe. So let's switch back to the presentation now. And I want to talk about something else that's maybe not so clear, and that is the distinction between a cloud service and a virtual machine. The way you might have heard cloud service being pitched at you is that a cloud service is the cool, wonderful thing that where you put your web and worker roles in, it's platform as a service. Well, to be more precise about it, a cloud service is a container. It is a management, configuration, network, and security container. So it just so happens that up until this point, we only had PaaS virtual machines that you put in this container. You can see here that we've got a web role and a worker role with a number of instances in each one. Each instance is an actual virtual machine, a stateless virtual machine. But because they're in this container, that means I can deploy them together, I can delete them together, I get billed according to that as one holistic unit. They're within the same security boundary from in the future, they'll have their own identities and be able to access each other as that same service, access other services as that service identity. But also, from a networking perspective, they are in the same virtual network. We just never called it virtual network, but there's a virtual network there, so they can see each other. You can ping the machines from each other. You can RDP to each other without having to go into an open endpoints on the cloud service itself. If you want to access it from the outside, of course, you tell Windows Azure Networking that you want to open ports outside the container to let people in. So if you had a web role, for example, you'd open port 80 as an input endpoint to let the outside world get in to this container. But when you go to the portal, let's switch back to the portal real quick. When you go to the portal and you say, I want to create a new virtual machine, you know that from the demo this morning, that for example, if I pick one of these, that what's going to happen when I get to this dialog is I get asked, do you want to create a standalone one or connect to an existing virtual machine? So let's go back to the slides and I'll explain what the distinction is there. When you create a standalone, there's the roles and the instances. When you create a standalone, if I'd said yes, I would have seen a virtual machine show up in the virtual machine list, and I wouldn't have seen a cloud service show up for that. When in fact, underneath the hood, we do create a cloud service. It's an implicit cloud service. It's got the same name that you gave as the DNS address of that virtual machine. And we did that to make the first time somebody coming to the Azure and saying, I just want to create a virtual machine, they don't have to learn about what's a cloud service. They just think, I'm creating a standalone virtual machine. But there is, like I said, a virtual machine, cloud service underneath there. When you add a second virtual machine, like if I'd said, connect to an existing virtual machine, then that cloud service surfaces up because now that's something that you need to know about. So when you go to the cloud services menu entry in the portal, you will see cloud service. And now it's very clear that these things are part of the same container, part of the same security and network and management boundary. Also, if you use PowerShell scripts, PowerShell doesn't hide that stuff from you. It's just aimed at people going to the portal, kind of clicking through things. So in PowerShell, you will always see the fact that there's a cloud service. Even if you're creating a single virtual machine, you will specify the name of the cloud service. Let's go back to the portal, and I'll demonstrate this by these two concepts. So if I go and I look at cloud services, I can see that I've got that 16 disk machine sitting here in a cloud service. Now, this got promoted to a cloud service because I'd previously added a VM to this, so it got promoted. I removed the VM. It still stays as cloud service. Once it's promoted, the portal never tries to hide the fact from you that it was a cloud service. But if I create another virtual machine now, which I'll do using PowerShell, so let me go to PowerShell scripts here, and I've got a script here that will create a Linux virtual machine. So I'll say edit, and let's take a look at what this PowerShell looks like. So you can see these up here at the top. I've picked a subscription that the PowerShell then scripts are then going to the command list, or they're going to reference. So that's going to pull the management certificate out of there. Then right here, I'm telling it which image. This is setting a variable saying that I want a canonical image, that the username I want to be Mark Russ, and that I want to name the VM Linux 1. And then here I define the new configuration. You'll create the new VM configuration here with the image name, the password. I say that I want instance size small. I configure the Linux things, and then you can see here, here's the service that I want to add it to. And so that's a required PowerShell parameter. And then once I'm down here, we're going to see that it's going to wait until the endpoint's created and then tell us that that machine is up and ready for me to SSH into it. And what I'm going to do is just run that. And this will take a few minutes to spin up that Linux virtual machine. It'll put it in that same cloud service as the 16 terabyte machine. Let's make sure that it have the right TechEd IaaS, TechEd 2002 IaaS. So let's go back to the portal. And there it is, TechEd 2012 IaaS. Once that's in the same virtual machine, what I'm going to be able to do is putty into the Linux machine and then ping directly the internal IP address of that Windows Server 2012 machine using the name, its machine name. And I'll explain why the machine name shows up as well now too, something that used to not happen in Azure up until the release of these features. So we'll come back to that in a few minutes. Let's switch back to the presentation and talk about some of the availability features we've got added to this release as well. So you saw this morning that we were creating a big SharePoint farm. And when you got a SharePoint farm, you don't want it to go down. This is one of the downsides, actually, I think, and the advantages of PaaS versus IaaS is that in the IaaS world, each machine is kind of a unique state. It's a unique entity. So you babysit it, you coddle it, you feed it. And with the PaaS world, basically the only thing that you care about is the image. You don't care about the machines because those come and go. They're easy to create, easy to poof up, easy to scale out. But nevertheless, we want to make sure that if you're going to migrate server applications up, that you can create services with them that are highly available. So one of the things that we also wanted to do is say, we've got a promise. We're going to make a promise to our customers about what kind of availability they can expect from us, so that you just don't have to go guess or experiment to see how available we are. We're going to say we're going to have a certain availability or above this level of availability. If we get below it, well, then we owe you. And the availability that we've got for at least 2 instances as part of the same cloud service is 99.95%. This is the same availability that we had today, and actually we've had since the release of Windows Azure for cloud services. If you've got 2 instances of your web role, you're signed up for our 99.95% SLA. If you only have 1, then you're not qualified. Because the idea is if there's a failure in the data center, we can keep your app up because the load balancer is going to start routing traffic to the other VM. For single instance now, we know people are going to be putting VMs up where there's only one instance. And underneath the hood, instance really is a role. It just has one instance in it, unlike PaaS, which can have multiple. And we knew that people were going to come to us and say, what's the availability for these guys? And so we thought, what number can we come up with for availability? So 99.9 sounded like a nice round number. So we said 99.9. Actually, we've done the math on our data center availability and operations. And this is the availability that we're going to honor. It's not in place today during preview while we're making sure that we can meet it. And we fixed any issues that stop us from meeting it. But it will be in place at general availability. So this is what's coming, is 99.9% for your single instance VMs. And I want to point out that this is a differentiator between us and other public cloud providers, or the other public cloud provider. And that if you go look at their SLA, it says 99.95, and it doesn't talk about you, it talks about their regions. So go read the fine print on their compute availability. It'll say 99.95% of the time a region will be available. Nothing about a server, nothing about racks, nothing about even different areas inside of a region. We are actually saying, we're saying it about your server is 99.9. And what's included, of course, are things that are under our control. So hardware failures, platform software updates of the host OS on the hypervisor, any downtime you experience because of that, periodic maintenance, that counts against us. What's not included, of course, is things you do in your VM. We can't stop you from going in and making your machines unbootable, but we can handle our side of things. So this is an example of where if you had a single SQL server, you're going to get a 99.9% SLA for that single SQL server. Because we support SQL mirroring, and we will eventually support failover clustering as well, you can get a higher SLA by using those kind of availability technologies at the application layer. So this is, again, the 2SQL mirror example, like you saw in the SharePoint application in the keynote, where now you're going to get the 99.95% SLA across those two machines. How do we do this in the data center? And what happens underneath the hood when we do a platform update? How does that relate to this, and how do you actually tell us that these two machines are related? Let's talk a little bit about two concepts that, if you're familiar with web and worker roles, that you already know about: fault domains and update domains. So with fault domains, what we do is model our data center and identify any single points of failure. A server, and like I mentioned this morning, a top-of-rack router, a TOR, are single points of failure. If the TOR fails, all the servers in that rack are inaccessible. So with fault domains, what we do is when a service has a number of fault domains that it requires, when you deploy that service, the instances of any particular role get spread across fault domains. And I'll show you a graphic on the next slide to highlight that. Similarly, when it comes to updates that you make to your cloud services, like your PaaS services, your web role or worker role, the platform supports update domains so that it will only bring down a part of the application, a part of the role at any point in time, update it, and then move to the next slice. These update domains, you get by default 5 of them. You can request up to 20 of them for your PaaS roles. So you can have it so that at 5% of your tier, your role, will be down during your planned maintenance of that tier automatically, just by giving us the update, and then we do the marching through update domains, making sure each slice is healthy before we march on to the next one. We also take advantage of update domains in another place, and that's the platform servicing. So we do have to service the platform underneath the virtual machines for security reasons and reliability reasons periodically. Today, it's about once a month. And that happens when, of course, you know about what time of month that's going to happen. It's related to. Now, what we're hoping to do is, because there's a reduced threat surface area in the data center, is skipping any that are non-critical and just releasing updates to the core OS that might affect those critical patches as well as major reliability improvements. And so we're going to try to get down to every 2 or 3 months for the planned maintenance that would require downtime of the VMs. Now, that downtime of the VM is about 20 minutes as the host OS shuts down, reboots, and then the VMs come up. And again, that time counts against our SLA. So when we take a PaaS application and you deploy it, let's say we've got a web role with 4 instances, we've got a worker role with 4 instances. What the infrastructure, the fabric controller, which you can hear about more on Wednesday when I talk about Windows Azure internals, is going to do is spread these guys round robin across update domains and fault domains. They're not really directly related, just in the fact that instances get round robined across them. And by default, services get 2 fault domains. I mentioned they get 5 update domains, but 2 fault domains. That's today. In the future, you'll see us offer more than 2 fault domains for stateful services that store their data locally and want to make sure they can tolerate multiple failures. But today what happens is we'll round robin. We'll say these 2 guys are going to, 2 of each, half of each are going to go into different racks. And that means that if a rack fails, that we're not going to lose the whole service. In fact, we'll try to spread them out across more than 2 racks, but we guarantee a minimum of 2. And then update domains, too, are applied into pairs as well. So we will not we'll make sure that update domains and fault domains at least don't conflict with each other. But now when we service the servers, we'll not take down more than 2 at a time. So with virtual machines now, we wanted to say, how do we give this capability to virtual machines? Because you have single instance roles. It's not like you can say, create IaaS front end for virtual machines persistent in the same role, because that's not the model that we've got underneath. We wanted to make it possible for you, though, to take advantage of availability with the way that the PaaS guys do with fault domains and update domains. And so what we introduced is the concept of availability sets that you saw me demo in the morning, show you in the morning. When you put multiple virtual machines in an availability set, it's effectively making them a virtual role from the perspective of a platform. So just like for the web role or worker role, we'll spread these guys across update domains and fault domains. We do the same thing here for the instances that are part of an availability set. So we'll put each one of these in a different rack. 1/2 of each availability set that we've got there. 1 availability set, for example, for the front end, and 1 for the back end. And similarly, they'll also go in update domains as well. So now when we service the host software periodically, we'll make sure that we only take down part of your front ends as well. And for example, if you had a scale out front end where you had 20 front ends, you could request, again, 20 update domains, and that means that we would march through servicing the servers underneath such that only one of them would be down at any point in time. So let's take a look at, in the portal at configuring availability. And for that, I'm going to show you an example application that I've got here. It's this application here. If I go into FabricCam Cloud Apps, you can see the list of instances that I've got in it. This is a 2-tier app, a web front end, and a SQL backend. In fact, it's the same application you saw me show this morning, this Event Manager app, except I've broken it into 2 tiers. It used to have the SQL database sitting there right on the same server as the IaaS front end. So I've broken it into 2 tiers. I've also scaled it out so that it can be highly available. So here's the front ends. Here's the SQL witness for a SQL mirror there on the back ends. And if I click on the front ends, again, I can go to configure. And what I'm going to see is that it's part of an availability set. And now those 2 front ends are part of the availability set. So it's exactly like the diagram I just showed. We're putting them in different racks. And we're going to service the servers underneath them independently of each other. So let me switch over to my laptop and show you that a tool that we've got called Fabric Viewer that will let me look, as somebody that can access these kinds of tools internally, at the placement of services in our data center to show you that these are actually on different racks. This tool you might have seen me show in my Windows Azure internals talk. And to figure out how I can look up this service, I'm going to click on it. And down here, you can see that I've got a deployment ID. It's C0 whatever. So let me paste that or copy that into the clipboard. And now I've got this Fabric dashboard, which shows us lists of what we call clusters, roughly 1,000 machine clusters across different data centers. And I've identified through another tool which cluster this service happens to be deployed to. And if I paste the deployment ID in here, you'll see some of the servers for some of the virtual machines get lit up in green. And this is actually that service that we were just looking at. One of the virtual machines. These are virtual machines. I think I had medium virtual machines, which are 2 cores. And we have 4 virtual machines to look for here. There's one. You can see there's a yellow one right there. There's another one. There's another one. And there's another one. And they're in completely different racks. And that's, of course, intentional by the platform's placement. Let's switch back now. Let's switch back to the slides, please. Let's delve into Windows Azure networking now, because we've added a bunch of new features in Windows Azure networking to enable some cool scenarios, some of which you saw a little bit this morning. I'll delve deeper. One of the first things that we're doing is we're giving you full control over machine names. So when you actually create a machine now and you give it a virtual machine name, that name is one that you picked, and also it's registered with what we call Windows Azure DNS, or Windows Azure provided DNS. So that means it's registered in the DNS namespace for the cloud service, and that means that name is accessible for lookup by any of the machines in that cloud service. Let's switch back to the portal view, and let's see how our Linux VM is coming. So here's my Linux VM. Let's get its SSH requirements. So it's SSH details here. And I'm going to run putty, which is a little SSH applet. And this is the port. This isn't the standard SSH port, and I'll explain why not shortly. I think it's administrator. Is that what I put in? Yeah. Oh, actually, let me make sure the, what did I have for PowerShell here? Mark Russ. Let's try Mark Russ. Oh, let's try that again. Go back to the portal. Did I close the portal? Oh, there it is. And get that DNS name again, and paste it, and do Mark Russ. And now log in, Mark. That was my pass. Oh, I have to kill putty completely? I did quit putty completely, actually. All right, so this is 54. I just did this, so it worked a minute ago. Oh, I didn't press. Oh, the enter key stuck. That's what the problem was. Yeah. Whoops. It's memorizing 50 different passwords that we're using up here. Okay. Let's try that one again. I feel like that. Yeah, I'm in. Isn't that awesome? All right, so let's ping the, like I said, this is part of the same cloud service as this 16 terabyte machine that I created early. So let's go get the virtual machine name from it, which is server 2012 16 terabyte. So let's see if we can ping. And I already opened up the firewall on that guy to allow pings. Oh, ping, ping, yeah, thanks. It should be smart enough to do that, shouldn't it? And there we go. It's part of the same internal cloud service network, so they can ping each other. Yeah, thank you. Nobody else is impressed? All right. All right, let's switch back to the PowerPoint. I'm going to talk a little bit more about that. But speaking of DNS, so you get that default DNS that's part of the cloud service, but you can bring your own DNS now as well. So you can bring your own on-premise DNS through the gateway technology I'm going to show you, point the cloud service at a DNS server that's back on-premise. You can actually deploy a DNS server up into Windows Azure. So, for example, I can deploy Active Directory, have it serve as dual purpose as a DNS server, and then serve DNS names for the entire domain that would be up there hosted in the cloud. And I also, of course, can use a public DNS service as well. And I'll talk more about virtual networking in a second, but I want to talk about some of the other features that we've added. If you've been using Windows Azure for a while, you know that there's certain protocols that we didn't support. Some of them that have prevented certain kinds of applications from being deployed to Windows Azure. A big one, for example, is UDP. So we only used to support TCP protocol. Now we support UDP. And that means that a lot of applications like games and media streaming now can work great on Windows Azure. In fact, we support all IP-based protocols. So you saw me do pings with ICMP. We support dynamic ports, which I'll talk about in a second, how we take advantage of that. So big advancements at the core of the networking platform. We also have two capabilities that we've introduced. One's port-forwarded endpoints. And I'll talk about that in some detail next. We also have custom load balancer health probes. And I'll talk about that in load balancing for virtual machines also. So first, let's talk about port forwarding, input endpoints. As you know, today, when you create a cloud service, you get a single virtual IP address, a public IP address that's sitting there on the internet that you can use to access the various instances in that cloud service. When you create a web role, for example, and those virtual machines get created, they get port 80. They've got port 80 open locally, and the load balancer now is spraying across a virtual port 80 to those internal port 80s. But that's fine for load balancing, but let's say that you wanted to go hit a particular one. Let's say that you wanted to, for example, RDP into one of those instances. Well, for virtual machines, this happens a lot. You want to access a particular one. And when we create, the most common example is the RDP file that we create for you. When you go to the portal and you say connect, we deploy an RDP file back to you. And then you launch that RDP file, you know you're connecting to a particular virtual machine. And the way that we do that is that each virtual machine automatically gets assigned its own unique IP address on the public VIP. That when you hit it, you basically are going through the load balancer directly to that one, not getting sprayed across other ones, because the load balancer knows who you're trying to access. And I'm going to show you an example of that in a second. Now, I just want to talk about roadmap here. I mean, we've got a single IP address per virtual machine, which kind of forces this behavior. It's actually can be useful in some cases, but we're almost certainly going to be adding capability to add multiple virtual machines to cloud services at some point in the future. So let's switch over to the portal and let me show port forwarding. So with port forwarding, again, each one of these instances that are part of this Events Manager cloud app is I want to be able to RDP into any of them. If I go to endpoints, I can see that I'll see the same thing for each of them, that there's an input endpoint here sitting on the virtual IP address. I've got an endpoint published on it that says, I've given it a name, so you can give it whatever name you want to. If you create a virtual machine in the portal, you will automatically get an RDP port forwarded endpoint for virtual machines that are running Windows, and you will automatically get an SSH port forwarded IP endpoint for any machines that are running Linux. This happens to be Windows, so it's getting the default RDP one, TCP protocol, public port, and there you go. And here's the internal port. So this is dynamic IP port, dynamic port, so it's just picked out of the space randomly and assigned to this VM. And now if I want to RDP to that, I can RDP to the public VIP and that port, and I'm RDPing directly into it. And I don't have to do anything special on the VM side. I just open up port 3389. The port forwarder knows map 55182 to 3389. So if I go look at another one of these virtual machines, like this one, I'll see that it's got a different public port here. It's going to be sitting on the same IP address, different port to go access it. And when I say go connect, I'm going to get RDP file that has that programmed into it. Okay, let's switch back. The other capability we had, I mentioned it this morning in the keynote, is load balancing. So load balancing in Windows Azure for PaaS applications is extremely simple. You basically create a web role, and then you say, I want to map port 80 to this web role. And that means as that web role scales out in instances, the load balancer is going to automatically include those instances and spray across them to port 80s. Again, we said, how do we do this for virtual machines, which are single instances, single instance roles? Basically, I want to spray across different roles. How do we do that? So we came up with this concept of load balance sets, which is effectively creating a virtual role, again, just like we did with availability sets, out of virtual machines. And once I've put virtual machines in a load balance set, the load balancer is going to automatically spray across them. So I specify which public port again, just port 80 if it's the web front end. Internal port, port 80 because I don't want to mess with that. Protocol is TCP, and the name I'll call it web load balancer. And now, because those VMs are part of that load balance set, anything coming into port 80 on that public IP address is going to get sprayed across those 3 machines right there. We also introduced custom load balancer probes. So the default behavior of the load balancer that we had up to this point was that it would probe you every 15 seconds. And if you missed 2 probes, it would take you out of rotation. Well, probing every 15 seconds, maybe that's not the policy that you want. Also, maybe you want a more frequent probe. Maybe you want a number of missed probes to mean that it's unhealthy and take it out of load balance. Out of the load balancer. You know, the smaller that you make the probe, the more quickly you're going to start to detect a failure. But you might say, I'm not going to give up on this until I detect it's failed n number of times to respond. And you can also specify a custom URL as well. So you can say, I've got a load balance set. It's got these virtual machines in it. But this other virtual machine over here, he's going to be responsible for responding to load balance probes for the different virtual machines on that load balance set. So basically, I could have something sitting on the side that is kind of reporting on the health of those virtual machines and whether the load balancer should forward to them, all done with custom probe. And all the probe has to do is return success, OK, and then the load balancer will consider it healthy. It starts to respond with anything else, or it takes too long to respond, and that's when you start counting against the probe timeout, or the health timeout, which is then going to kick the thing out of the load balancer. You can apply this, by the way, like some of the other advancements we've made here in networking, not just to virtual machines, but also to your PaaS roles. So now you can create custom load balance probes for your PaaS worker roles as well. So let's switch back and let's take a quick look at load balance sets in the portal. Again, this web role, we've got it on the front end at port 80. And I can see that it's part of a load balance set here by the fact that the port 80, just like we had just mentioned in the example, public port, private port is port 80, and it's part of the load balance set. And when we edit the endpoint, we could actually, oh, I clicked on the wrong port, on the wrong input endpoint. Then I can see that it's load balanced as part of the other. And so effectively, it's created a custom role for these guys that the load balancer will spray across. Let's switch back. Let's talk about connectivity, site-to-site connectivity, and machine-to-machine connectivity. Anybody play with Windows Azure Connect, the point-to-point connectivity solution we introduced about 1.5 years ago? So what that does is let you stick an agent on a machine on premises. I guess somebody scolded me for not saying it properly. It's not on premise. It's on premises. So I apologize if I offended anybody this morning by saying that. So on premises, you got a machine on premises, you put the agent on it, and you wire it up to the Windows Azure Connect endpoint up in the cloud. And now the machines that are part of the cloud service that Connect endpoint's part of, because you've stuck the plugin in them, is going to be able to have a private IP gateway tunnel between the cloud service and your machine on premise. And you could effectively treat it as if it's on premise, a part of your local network. The problems with that, I mean, that has some great applications. For example, dev test. I want to create a private tunnel up into my machines that I'm testing in the cloud. I don't want to put them on the open internet while I'm messing around with them. And I want to just use my local tunnel. That's one example. I want a domain join through a private connection back. The downside of that is I got to stick the agent on the domain controller itself to have it see the cloud machines. So we've gone a step further now with Windows Azure networking with site-to-site connectivity. So that's what I'm going to talk about now. It's built on a technology we call Windows Azure Virtual Network. And Windows Azure Virtual Network has capabilities that are useful by themselves in the cloud, as well as for creating a hybrid scenario of connectivity of the cloud to on-premise. The hybrid one is, for example, I want to again, take these machines up in the cloud and domain join them, but I don't want to put an agent on my domain controller. I do the standard, more enterprisey thing of creating a VPN device, wiring that up into the cloud, and then projecting subnets up into the cloud that those virtual machines now are part of, so they can appear on basically the IP space of my corporate network. And then the other example, like I mentioned, that use case for virtual networking is without the gateway, just to connect different cloud services together in a virtual network. In fact, the way I think of it is a cloud service. Remember I said it's a container for management and for security and for networking. I think of it as having its own implicit virtual network. You saw that I was able to ping one machine from another. Their IP addresses are all visible to each other. They've got their own DNS name resolution. What virtual networking does is takes that concept and lifts it off, and now I can put multiple different virtual machines and cloud services into a virtual network so they can see each other. So this is an example of where somebody would want to create a cloud service where your backends, you don't want them sitting out on the open internet at all. So I've got my front ends there that are listening on port 80, and now my backends with my SQL database in it, they're accessed only from the front ends privately by their IP addresses or by their names with a DNS server that's either up in that cloud service, one of those cloud services, or on premise, or a public DNS service. And now they can talk to each other without my SQL databases being exposed on the open internet. Here's an example of this particular application we've been looking at, this two-tier application. I've actually domain joined those machines. And not only that, but they're part of a directory that has a domain controller that's on premise. It's got a domain controller up in the cloud, just so that it's close, but it's part of the same domain as is on premise. 2 sites in the directory. So this is the architecture really of what we've been looking at, and now I'm going to focus in on the VNET part of it. So let's switch back to the portal. And the fact that we can see that it's part of the VNET is if I go over to virtual networks, or networks, you can see I've got this app VNET here. And this gives me the information about it. I've got 3 subnets. The back end is where the SQL databases are. The front end is where the IaaS servers are. You can see a gateway VPN that I've named Corp on-prem. And you can see that I've got 2 DNS servers configured. One's in the cloud and one's on-premise. So now, if the cloud one failed or the on-premise one failed, I still can do DNS name resolution because I've got a pair of them going. You can see as part of the VPN, I've got statistics on how much data is flown in and out, as well as the IP address of the gateway device itself. And then the machines that are all part of this gateway. So you can see I've added a whole bunch of machines to it. These are the virtual machines that we've been looking at. They're added to that gateway. Let's take a look at how that gateway actually works by RDPing into the domain controller that's in the cloud. So I'm going to connect here. Let's see, password 1. Oops. And actually, let me show you this first. So this is the domain controller sitting in the cloud. And then what I've done is just RDP into the domain controller sitting on premise by its IP address. And that IP address right there, 192.168.1.6, let's go take a look at where I got that. I got it. I got it right here. Right there. You can see these are the DNS servers. So I've configured those direct domain controllers to also be DNS servers. So I said, oh, how do I know the IP address of that domain controller on premise? Well, I'll just go to the gateway configuration and then look at what the DNS servers are configured. There's the IP address. So you saw me RDP to that IP address. Now I'm actually RDP'd into somebody's machine under a desk and sitting in an office in Redmond that's being a domain controller for me. And then you can see also here the way that the subnets are carved up. This is what your network administrator is going to do is say, you want to create a VNet up into the cloud, tell me, I'm going to go configure the VPN gateway, and we need to give subnets out so that you can deploy virtual machines into various subnets up into the cloud, like we saw. And then you can also see, you might have caught a quick glimpse here, is, did I close that RDP connection? I didn't mean to. Let's RDP again. Because that machine is also where I can manage the VPN gateway from. The VPN device, and you probably saw, there it is. There's the VPN gateway device, and if I go to configuration, this is where you can see the various subnets wired up that we saw in the virtual network UX. So now I've got this example of the hybrid tunnel backed on premise, those machines all domain joined, all with Active Directory sitting up in the cloud for locality and for high performance, and yet they're also being synchronized with the on-premise Active Directory through that gateway. Let's switch back. So this is just an example of a hybrid type application that I just showed you. Now let's talk about what I think makes us unique and kind of the path that I see us, many people going through as they come to Windows Azure. Again, adding virtual machine capability, that's a great stepping stone to bring your stuff up into the cloud, to take your existing applications. And there's going to be different kinds of applications you're going to put up into the cloud, right? There's going to be the ones that are your apps that have been chugging along. You haven't touched them in years. They're doing their job, but I don't want to have to manage the hardware underneath them or the virtualization underneath them. I just want, let's push them up into Windows Azure. And then I'll never touch them again. They'll live out their existence peacefully and quietly, hopefully never causing me any problems. And then there's the other ones where you say, this is a complex app, and I bought into platform as a service and the benefits that it gets me of just having to worry about the app and not all the stuff around it. So what I want to do is take that app today and migrate it to the cloud. It's fully infrastructure as a service. I'm managing individual virtual machines. And then I want to take it on a road of investment because this is an app that is actually going to grow and it's a key part of my business. And so I want to maximize the efficiency of this application. So I'm going to take it on a trip into the world of PaaS. So let me show you some of the things that we're thinking about for people being able to go on that journey into the beautiful world of PaaS. And here's the marketing slide of why PaaS is awesome. But this is really, truly what we believe. PaaS is awesome. We want to be great at IaaS, but we want to be great at PaaS, and we want to be great at bringing IaaS forward into PaaS. So one of the things you can do when you want to mix PaaS and IaaS, let's talk about different ways that you can mix them as you create these applications that are combinations of the two. One is that you, for example, have your front ends that you want that are PaaS. They're new parts of the application, and your back ends are IaaS. They're SQL. There's different ways you can connect them through VIPs. You can connect those parts of the application through VNET. I'm going to show you slides showing each of these architectures. And finally, eventually, you'll be able to put them in the same cloud service. So how about connecting with VIPs and the pros and cons of this approach? So with this, there are two discrete cloud services. We've got our web roles, our PaaS roles in one cloud service. We've got our SQL databases, IaaS roles, VMs, in the other cloud service. And they've got public endpoints. They've each got their own VIP. And they can talk to each other through the public endpoint, through the load balancer. That's just possible today. No special magic. In fact, the system doesn't know that there's PaaS or IaaS, behind each one of these doors. Just that it's doing the appropriate network routing. Now, the strengths of this approach, you get to manage and deploy the lifecycle of each of these independently of each other, because they are two cloud services. So there's autonomy in managing these things. You get VIP swap. Now that's something that we don't have today. Like I mentioned, VIP swap is a PaaS thing. It's where you deploy a brand new version of the service, and then you take the production IP address and you flip it over to the new instance. Well, think about that with virtual machines. Let's say I've got a cloud service with SQL instances within it. How do I deploy another version of that whole service with new virtual machines having SQL in them without on the flip over losing data, because my SQL databases over here don't reflect the state that they had over here at the time of the flip, only when I actually synchronize them in the previously. So VIP swap is a lot harder and trickier to do when you're talking about persistent VMs. So here, you can still do VIP swaps on the front. You won't VIP swap on the back, of course. Then the persistent service is easily accessible through even from other services through that front end. The weakness is you're going through the load balancer here. How much does the load balancer cost you? It's about half a millisecond in each direction. It adds to the transit time, a little under half a millisecond. So you're paying that overhead, whereas if you went direct to direct without going through the load balancer, you wouldn't pay that overhead if they were part of the same cloud service, for example. It's a little less secure because now you've got your SQL server sitting there on the open internet. So if somebody could hack at that front entrance, maybe get in. And it's got the management and deployment overhead. You're actually managing two services. This next option is connecting them with VNets. So we've seen how VNets, I can basically connect a hybrid scenario. How about connecting cloud services to each other with VNet? Now in this case, I've got two cloud services, and I can deploy them both to the same VNet. What that does is their IP addresses now are visible to each other. And if they've got a common DNS server, they can also do name resolution against each other. So it's more secure, low latency. You're not going through the load balancer. You still get the autonomy of managing two services. You still get VIP swap on the stateless services. It's got advanced connectivity requirements. It satisfies those. The weaknesses are VNet. You've got to know a little bit about networking and subnets to mess with VNet. So it's got that downside to it. It also, we don't have Windows Azure provided DNS for VNets. Now let me clarify what I mean there. You notice that with a cloud service, you can look up the names of other virtual machines that are part of the same cloud service using DNS. Implicit DNS that's part of the cloud service VNet. Well, that cloud service DNS service, we haven't glued it to VNet. So VNet, if you take a VNet and you put two cloud services in it, they each have their own DNS, but there's no DNS that encapsulates them both today. So that's something we're working on too. In the future, you'll see VNet with DNS as part of that whole bubble, so you can put everything in it. So you'll need to bring your own DNS. Put your own DNS server up there or connect it to on-premise DNS server. So let's take a look at Events Manager. I'm going to migrate that app. Remember, what that app today is IaaS front ends, SQL Server back end. Let's take a look at how we can take that app and migrate it to PaaS, start to migrate it to PaaS. Let's switch over to the demo machine. And so if I launch Visual Studio, here's that app right here, the Events web app. This is what I've deployed into that IaaS front end. Now let's say that I want to take that app and I want to add an existing project. I want to create a new project. Add new project. And I'm going to turn it into a cloud service. This is part of the PaaSifying the IaaS web role. So I'm going to call this Fabricam Cloud SVC. Say OK. I don't have to add any roles because what I'm going to do is take that web app and make it into a role. So I'm going to say OK. And now I'm going to say roles, add web role solution in project. And there it is, events.web. And bingo, I've just PaaSified that IaaS project right there, so into a cloud service. The last step I'll have to do is wire it up into the VNet. So I can go to the cloud configuration here, and I've got the snippet to show you how you would do that. Today that's not possible in the tooling. That will be coming in the future. But this is what that snippet would look like. So remember you saw that app VNet that we had up there? That was our virtual network name. And what I've said is this role, which matches what I just created, that I want to put it in this subnet right here, the front end subnet, which you also saw on that list of subnets that were created for that VNet. So now when I go and publish this thing up into Windows Azure, it'll be a new cloud service, part of that VNet. And because the connection string, which is in web deploy to the SQL server, is unchanged, and because there's DNS, because we've got the Active Directory domain controller as part of that VNet, I've got DNS lookup, and so I don't even need to change the connection string when I deploy this, which I already have. Let's switch. Oh, no, sorry, don't switch. If I go back to the portal, and look at cloud services, that is this right here, this cloud service, which is now just the two front ends, and they're connected. They're part of the VNET, and they're talking directly to that back-end SQL database. In fact, if I go back here, click on this, here's my standard app, now pulling the data from that back-end SQL server, to just like the full IaaS one that we've been looking up into this point. Now let's say that we wanted to go this full way. This is we want to take, let's switch back to the slides. Actually, let me just show you. The full way, let's switch back, is to take that, that front end, and instead of having it talk to SQL Server, have it talk to SQL Azure. What do we have to do to make that happen? It's as easy as going to the web config, web deploy, or web conf, where are we? You can see how often I mess with IaaS. Web config. And here's my connection string right here, which is talking to SQL Azure, or sorry, SQL Server. This is the SQL Server database. I'm not going to scroll over so you can see, there it is. And if you go back and look at what we had here, there's the data source, 10.3.4. That's one of the SQL servers. Remember, I had them set up in mirroring, so there's the failover partner right there. And what I want to do now is flip that to a SQL Azure connection string, because what we've done already is migrate that database into SQL Azure. And so I just need to paste in the SQL Azure connection string, which is now this. That's the database that we've got up there. And we've taken that app and deployed it as well, and it's right here. This is, again, the front ends now. They're going to be talking to SQL Azure backend. And it's going to show us the connection string that it's using on the front page when we log in. Here in a second. And there it is, the SQL Azure database string that you saw me put in that web config. So this is an example of how we see a kind of canonical two-tier application start to migrate. Let's switch back to the slides and wrap up with where I see us going. Slides. Slides. Bueller. Okay, so I'll pretend that we've switched to the slides. And on the slide, you can see PaaS and IaaS in the same cloud service. Mixed mode is what we call that. This is something that we made a reach for in preview. We didn't quite make it, so it's definitely coming. And this is where you'll be able to take what we just saw, the SQL Server instances and the web role front end, and put them in the same cloud service. And then you can manage them as the same security network and all the other characteristics, attributes you get from having a single cloud service. And again, when we get this multiple VIPs per service and VIP swap within a service, you'll be able to take and still do VIP swaps on the front end is the way that we see this going. I want to update the web roles. I'll deploy a new web role to the same cloud service. I'll apply a VIP to it, which is a staging VIP, to that role. Now the cloud service will have two VIPs, one that's the production VIP that's assigned to the older front ends, and the one that's assigned to the new front ends. Test it. When I'm happy, then swap those VIPs, the production and the staging VIP. And now I've just done an update of the front ends, left the SQL servers intact as part of that back end of that mixed mode. And so that's the way kind of evolution we see going, of course, with tooling that makes that stuff easy to do. And that's this last slide that you had to pretend was there. So the strengths of this one, you get the Windows Azure provided DNS, you get the low latency connectivity. And I think the big one is that it's a single unit of management, security, identity, as these things get identity in the future. Billing, access control. The weaknesses that today, no VIP swap, that you'll, as I mentioned, we're working on. And that is the pure PaaS that I just showed you. So that brings me to the conclusion, and just to summarize our goals, let's see, just review them to see if we hit them. IT Pro Experience, PowerShell scripts all over the place, and there's several sessions going on this week where there's deep dives into actually how do you do this stuff all with just script. And scripts give you a lot more power than what you can get through in the portal. Of course, the automation is nice. Support for key server applications, you saw this morning. SharePoint, you saw Active Directory, you've seen Active Directory here in SQL. This list is the initial list. We've got more applications coming and being certified. We actually have it as what we call a common engineering criteria for server applications to support Windows Azure, just like they have to support Hyper-V. So you're going to see more and more start to show up in that list as this teams make sure that they work properly and if there's any corner cases you need to worry about. Easy storage manageability. Again, it's all Windows Azure storage. Underneath, easy in, easy out. High availability features you saw with availability sets, load balance sets, custom probes, the ability to connect to hybrid back on premise, so you get availability there for things like Active Directory, advanced networking, the virtual network technology, and then the gateway feature of the virtual network technology to open up those kinds of scenarios, and then finally our roadmap for what we've got today for integrating PaaS and IaaS, as well as where we're going in the future. So I think that we're off to, I feel really good about our start, especially this is the V1 of our virtual machine support. As, like I said, it's just the beginning. It's just the preview. And we've got a whole bunch of things coming, including performance improvements, some massive ones that I'll talk about on Wednesday, give you a look underneath the hood of what we're doing performance-wise with IaaS, as well as fleshing out some of the more of these features that you've seen the start of. So I really hope that you kick the tires. Go sign up for a preview account. We've opened up enough subscriptions to make sure that you guys can all get into the program. If you can't, send somebody mail. Send me mail. So feel free to send me email, and I'll help make sure that you get an account. There's 2 sessions coming right after. This is part of the Learn Windows Azure. So right after this at 3 o'clock in about half an hour, Bill Staples is going to come up and talk about websites in some more depth. And then Quentin Clark's going to come back and talk about data services on Windows Azure as well. So I hope you enjoyed this. Hope this opened the doors, and there's a lot deeper information and content. Just check the guide, and I hope to see you putting stuff on Windows Azure, and hope to see you at my other sessions this week. Thanks very much. Oh, and then there's this. Who wants this? You do? For your 2? Anybody have somebody younger than 2-year-old that they want to give this to? All right. All right. Thanks.